Hello friends, welcome back to another video. Today's video is the second part of my previous video which I made on rational number. So to better understand today's video, I will suggest you to please watch my previous video, that is the video on rational number. And in today's video, I'm going to teach you the types of rational number. So let's get started. So in my previous video, I taught you about what are rational numbers. So now we understood what is a rational number. And we also got to know how to represent them. So we generally express them into their fractional form. Okay. But we also know that we can also convert them into their decimal form. That is decimal expansion. And after the conversion of the rational number into their decimal expansion, we found that they show some differences. And on the basis of those differences in the decimal expansion, rational number are of two types. First is terminating, second is non-terminating and recurring rational number. So we'll discuss each and every rational number types one by one. So let's start with our first type, terminating rational numbers. So we'll understand what is terminating rational numbers. So let's see what its definition says. The terminating rational numbers are the ones which when converts into its decimal expansion terminates means ends after certain decimal places. So here terminating means to stop somewhere, to end somewhere. But in the context of rational number, when we convert the fractional value into its decimal expansion and if the decimal expansion stops somewhere after the decimal point, right? Because in decimal expansion we have a decimal kind of number and we'll see if after the decimal point if the number stops somewhere or it keeps on moving and it's not stopping, the expansion goes on, it's not stopping. But in the case of terminating rational number, the expansion stops somewhere, maybe after one decimal place, maybe after 2, 3, means after finite number of steps, it will stop somewhere. So to explain it better form, I have taken one example and I have shown you the decimal expansion of that rational number. So in this case, the fraction which I have taken is 12 upon 5. Since it is a rational number because both the numerator and the denominator are the integer value and the denominator is not equals to 0. So yes, it is a rational number and the decimal expansion of this rational number, you can see it's 2.4. Now you can see that this expansion stops after one decimal place. Means after that decimal point, it stops at 4. So we can say it's terminate. It stops somewhere. It is not going and on. It stops somewhere. So this kind of rational number is called terminating rational number. So let's see the next type of rational number. So let's see the second kind of rational number, which is non-terminating recurring kind. So non-terminating recurring rational number in their decimal expansion show non-terminating, which is endless, and recurring, which is repeating behavior. Now this kind of behavior is completely opposite of the behavior which was shown in the previous case, which was the terminating kind, in which after the decimal point the number stops after 2 or 3 decimal places. Okay, that was the kind which was terminating, but this is the opposite, in which the non-terminating kind, after the decimal point the number is not going to stop, the expansion is not going to end, it will take you to the infinite number of steps. With that, there is a recurring nature also, in which the number which comes after the decimal point will repeat its value. And you can find this behavior as well in this rational number, the example which I have taken 19 upon 3, and in the decimal expansion of this rational number, you can see 6.3333, then dot, which shows that this is an infinite series of number 3. This dot show that it is an infinite series. This is not going to stop. Okay, that's why I shows dot. And with that, 3 repeating itself again and again. So it is a non-terminating and recurring kind. But you also know that you will not write any number which is repeating itself infinite times. Okay, you cannot write that way. So to write in the shorter way, there's a trick. You can put a bar over that value which is repeating itself. So here I have also mentioned that trick also. 6 point bar over 3. Now this bar over 3, a line over 3, shows that this 3 repeating its value. This way you can show the recurring nature of the rational number in its decimal expansion. So let's just see a few more examples of the rational numbers and try to understand it in a better way. So let's check whether the following rational numbers are terminating or non-terminating recurring type. So the first example is 5 upon 6. So in the decimal expansion of 5 upon 6, which is 0.83333 and so on till the infinite steps. So from this dot you can understand it is a non-terminating kind, and with that you can also find 3 repeating its value. It means it is a non-terminating and recurring kind of rational number. It's very clear from its expansion. It's not stopped. Second is 1 upon 5, which is 0.2 is the decimal expansion of this rational number. Now you can find this kind of rational number is a terminating kind because in its decimal expansion which stops after 1 decimal place and at the same time not repeating any value and not show the non-terminating behavior, the endless behavior, इसलिए this is a terminating kind. The next number is 42 upon 100. So in this decimal expansion is 0.42. So this is also a terminating rational number because the number terminates its value after 2 places after the decimal point, which is 0.42. So it is a terminating kind. The second last is 2 upon 13. Now in 2 upon 13, the decimal expansion is 0.153846, 1538 and so on. So with this you can find dot dot, it is a non-terminating kind. It is an infinite series of number. With that you can find there is not a single number which is repeating its value. It is a group of number which is repeating its value. So let's just read again. 0.153846, then after that 153846 is going to come, which means that 153846 is going to repeat itself again and again till infinite number of steps. So it is a non-terminating and recurring kind of rational number. And the last example is 13 upon 5. And in its decimal expansion, it clearly shows that it is a terminating kind because its value terminates after 1 decimal place. So yes, it's a terminating kind. So guys, we have reached the end of the video. I hope you have understood today's topic well. And if you really like this video, please hit the like button below. Do share it with your friends as much as you can. And if you are new to my channel, please do not forget to subscribe it. And stay connected with me. See you soon in the very next video. Till then, take care. Stay healthy. Bye.